Yeah, of course. Shoot.
I'm trying to make some flowchart diagrams for another course, and I learned about the mermaid package for Markdown, and it worked okay in our Markdown, but unfortunately it didn't let me include Greek letters, which is necessary. Do you know another path that might be more, beneficial to go down?
So what exactly are you trying to make?
Infectious disease compartmental models, like SIR model diagrams.
So what are they just like kind of path diagrams?
Yeah, it's boxes and arrows and then some Greek letters describing what goes between.
Okay. So you got a couple options. There should be ways to support Greek letters in using Mermaid. I would actually assume that there is a way because I've commonly seen Greek letters in ones that were generated in Mermaid. So the real question is how they're doing it.
Okay.
So one, I know that you could not necessarily in Mermaid, but indirectly via Mermaid use the diagrammer package, which is I'll type in. I think it's like diagram R, which should support.
Yeah, that's the one I've been trying to use.
Okay. So it should support.
Okay.
I can't imagine why it wouldn't. The real question is what is the necessary syntax to get it? And I'm not super familiar. Yeah, I'm not super familiar, but I mean, I've seen diagrams clearly made with diagrammer and the underlying stuff, both Mermaid and GraphViz that use Greek letters, among other things. So I know it's possible. The real question is just sort of how you go about it. And it really kind of depends what you need to do. Is this something that you need to have programmatically generated? That is, it's going to change depending on how the models run and stuff?
No, but I'm getting doc points for using pre-existing diagrams. They say do it yourself.
Oh, so what this is a class?
Yeah.
Okay. So that's one of those funny things where all of the real adults of the world actually manually make those sorts of diagrams by and large. But you get people who are like snobs and they will do things like dock people. It's kind of like how there's a sort of rampant shittery in the discipline of econ where they don't take people seriously unless they know LaTeX because they know LaTeX and it actually doesn't add any value. Like it pretty much there's no real value. It's just a torture they expect people to go through. That's sort of the same thing. So I do a lot of path diagrams all the time in my stuff. And I realized a while ago that unless I have to actually dynamically update components of it, it never results in a better look or a faster result to do them programmatically. It just doesn't. You make much prettier diagrams by, I mean, as an example, my crim class is littered with these sorts of diagrams. If I go to, probably this one, just lots of, let's see, yeah, no, give me stuff on, yeah, lots of, path diagrams like these and stuff like that. And a path diagram like this takes maybe 2 minutes to generate an Inkscape. And is going to look better than anything I do programmatically that takes me 30 minutes to do. And so I just do them that way. It's kind of stupid that people are like, they'll obsess over it. There are sometimes good reasons to do it. But it's really just if you're programmatically going to do it. In this case, you're sort of being compelled to do so, but you can at least sort of take some satisfaction in knowing that they're essentially just making you jump through a hoop because they prefer to do this thing, which they've probably wasted an enormous amount of their life doing themselves. So they feel other people should do it too.
Gotcha. So for real world Inkscape, you go from there.
Any kind of thing, Illustrator, Inkscape, that kind of thing. Unless you, the only cases where it's better to do it programmatically, like I said, is if you have to like update results. So
yeah.
I mean, I have a case here where I've got a programmatically generated one in this project. So this, for instance, is a programmatically generated structural equation diagram in this
Hmm.
repository. And so
Okay.
the reason it's programmatically generated is because I need to have the numbers in here update when the model changes,
Sure.
and the diagrams stay the same. But this took it a lot of time.
Yeah.
If I was only going to, like this diagram up here, I could have drastically faster sort of manually drawn this thing, though the LaTeX diagram like this looks quite nice, so I'm happy with it. That's about the only case where I'd say it's ever really worth it. And
Okay.
usually the programmatically done ones are actually substantially uglier. So you're
Yeah.
sacrificing both time and aesthetics, and the only gain you're getting is the ability to lord over other people.
Yeah, I don't need that this time. I just need to get this thing out.
Yeah.
Okay. All right. Thank you very much. I'll give the Inkscape a shot.
Yeah. Well, I mean, if you're going to get doc points for it, try and figure out how to do it with the diagrammer way. I mean, you got to, you do what they ask you to do. It's kind of like, if your
Yeah.
advisor tells you to do something, even if you're like, it doesn't really make any sense, I'm going to do it, because often they do like know better. In a class, they probably don't know better. But if they're going to mark you points down, do their thing, jump through their hoop.
It was more that I borrowed a pre-existing diagram. They don't care how I make it. It's just
Oh yeah, then don't. I mean,
yeah.
just do like Inkscape is nice because it's an open source vector drawing program. If you got Illustrator's basically does the same thing.
Okay. Cool.
Yeah. Any other questions like that? Random tangents that I can rant about?
Maybe speaking of hazing by academia, why did you give us this data set?
Oh yeah, that same thing. No, I can't. So the reason I gave this data set that I give it is because it's actually kind of a good example of the sort of data sets that after you've taken like a bunch of stats classes, you've taken some like basic R thing and you're like stat sequence, you go into the real world and suddenly realize you don't know how to do anything because real data sets are hideous and they're not laid out the way example data sets are. And it's actually sort of a tragedy that that's done. So what I do is I provide, this is the ugliest data set you'll encounter in this class. And I provide it so that after you've gotten all the fundamental ways to deal with it, you suddenly are just given something that's kind of ugly and hard to mess with, and you have to sort of muddle through it, because that's the real process of working with data. You're going to get some, especially if you work with like administrative data. I'm almost entirely work with administrative data. And this isn't remotely like, I wouldn't even consider this a bad data set by compared to the stuff I deal with on a daily basis. But for people who haven't done like real administrative data analysis, this is a horrific monstrosity. It's just like, it doesn't make any sense. There's rows that actually don't have information. With each precinct, there's at least one row that conveys no useful information. There's columns that are constants. I mean, just, it doesn't make any sense, right? And so if people don't have an experience with this, they're going to have all these great tools that they can work with on example data sets. And then you get up a real data set, they're like, I have no idea how to work with this because, the format makes no sense. And so I did do this, and this is a nice contained environment with little risk to experience this. And then you'll learn a lot of techniques in this homework that can be applied to similar sort of messy data sets later, like playing around with pivoting and things. Yeah, so it's done purposefully. Okay, so let's go ahead and grab it and start working. So let's see, not my email. I'm just gonna go ahead and I will download the data. Let's stuff it into this directory. Okay, pop that open and get moving on here. So first of all, let's make it me. Let's make it today's date. Okay. So the gist of this sort of homework is there's a fair amount of instructions in here. Some of them are incorrect, like saying it's due Tuesday, October 30th, because I forgot to update that. I really got to remove these specific dates. I'm going to forget to update things. But basically, you're going to be mostly following instructions around here. We need to load in this data set. And we need to kind of poke around and try and figure out the nature of this data set so that we can get some things we want. And the things that we want are mostly going to be arrived at next week rather than this week. This week is we're just kind of doing some initial cleaning on the data set. So the first kind of barrier is that we want to just load in this data set from I downloaded to a drive. It's better to save the file to the same like directory the RMD is in and load it locally rather than continuously pull it down off GitHub, just because you're burning 60 megs of bandwidth every time you do it. And GitHub doesn't really care too much, but you probably shouldn't do that. The first thing I'm going to do, though, and I would recommend that people normally do, is probably we're going to be using all those tidyverse functions that we've been using throughout the class. You might as well just load the entire block of them, and that's going to take care of most of the libraries we need loaded. We could theoretically load them individually, but there's not really much gain here to do it. So if I run this, it's going to load up most of the stuff we need. It's going to load up dplyr. We're going to use stringer. We're going to use reader. We're probably going to use tidyr, and we're probably going to use ggplot. Might even use forecast. So we're going to use most of the packages that just got loaded. Okay. So with that done, what we need to do, the very first thing we need to do is we need to import our data to work with it. So if I want to import this raw King County data, I'm going to say we're going to create something King raw. How would I import this data and read this file in and assign it to King raw? What should I do? Oh, yeah, I like the look of that. Okay, so here you've used read.csv, which works perfectly fine. I'm going to use the slightly different tidyverse one just because I'm consistent or trying to be consistent with it. So this is just saying, are going to read in a CSV file. We're going to read in King County Elections 2016. And notice that the file itself is a .txt file, not a .csv file. It is a comma-separated values file. If I go in here to look at it, the data are right here. If I open it up in my text editor, yep, only 60 megs, you're going to load just fine. If I load it up in my text editor here, wow, Adam's being slow. We'll see it's just comma separated values. At this point, my browser could have loaded it faster. What are you doing there, Chief? There we go. So it might be kind of hard to see. The text is a little bit small, but King County Elections, it's a .txt file, but it is a whole bunch of quoted values separated by commas. Each line is an observation. This is what comma separated values look like, okay? If you don't know what a file is and you encounter it, like if you just were given King County Elections 2016.txt, you could open it in a text editor like this, and you should be able to immediately see what the format is. If it's got a bunch of weird special characters, it's probably some binary format. Okay, so we load it in. If I run this, so this is going to run and this is going to work. The reason I can load it this way is because King County Elections 2016 TXT is in the same folder my RMD file is in, so it will just load it immediately. This is why it's kind of nice to put like everything together in one folder. You don't have to go searching through your computer to load it up. Okay, so what I'm going to do ahead here is I'm going to go down here to inspecting the data, and it says use glimpse to look at the data. Describe them in their current state. How many rows are there? How many variables? What values do they take? I've told you exactly what to do, so I'm not going to ask you how to do it. I'm just going to go ahead and glimpse. This is what you're going to get from the glimpse command. So glimpse, like structure, is going to tell you things like how many observations there are. You'll notice there's a lot of observations. There's 643,000 rows in this data set. That's a lot. This is the sort of data set that's too large for us to sort of manually pick through in Excel or something like that. So we're going to do everything programmatically, and we're never going to be able to look at the entire data set at once. It's just not feasible. It only has 9 columns, so relatively few variables, many rows. You'll see here it's got a bunch of columns that are pretty clear what they're probably about. If you know anything about the sort of structure of voting in, at least in like Washington State, precincts, voting precincts are the individual little delimited areas of space where people cast their votes. There's a lot of precincts in in King County. Race here, now race, you'll see here there's things like advisory vote 14 and stuff like that. This is probably things that they're voting on, right? Oh, so here's a question. What are the two numbers in rows? Well, there's 643,163 rows. It puts commas there as separators. So we have a column like race, so it says like advisory vote 14. But notice something about this immediately. You see how you've got like Adair precinct, Adair, 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 Adair. Okay. So we see immediately, before we even looked at the rest of the structure of the data, that clearly there's multiple observations per precinct. But not just that, there's multiple observations per precinct and per race, because advisory vote 14 is repeated many, many times. So we have sort of an interesting structure to the data. We don't have a data set where we just have like a precinct and then another column being the number of votes cast for something. We have some sort of weird long data set. We then have a few columns that we're like, what are these things? LEG, CC, CG. It's not clear what these things might be. We're going to look at them in a minute. We have counter group here. We're not sure what that is, but at least it has text values. Then we have things like party, counter type, and sum of count. And we're going to kind of work through and figure out what all these things are so we can continue working on here. Anybody have any questions so far before? You know, I've only run 2 commands, but things going good? Okay. So you'll probably write in and say some things about this here, a little bit of something. We'll skip over it. I'm only going to do typing in here to help with the code. So in addition, it says to looking at this sort of generally and holistically at the structure of the data, I want you to look at each variable individually, but we might consider LEG, CC, and CG at the same time. I'm doing this here to say these are not going to be useful variables to us, but we might be able to guess what they are. The idea here is that these are real data. They've got an ugly structure. Some variables are going to be indecipherable. If you were working on this for a real project, like you were actually out there and you had to use these data to convert into real voting numbers for, you know, some paper or something you're working at, you would probably just be thrown something like this and you'd have to figure out what all these things are, work through it, and, you know, come up with some result. And, you know, with little guidance, this could be quite difficult. I've given you a little bit of guidance, but not a ton. Okay. So this is an example of a way to quickly look at a limited number of values of some variable if you don't know what sort of structure it's going to take. Here I say you could take your data and then get distinct values of a single variable and then look at the first 10 distinct values. Another thing you might do instead is get a count of distinct values by doing count variable. Okay? I'll show an example of this right here. So we have our there it is. We have our King Raw data. So I might say something like King Raw count precinct. Okay, we're going to see something that looks like this. So what is this Adair 237 telling me?
That 237 observations have Adair as a value for precinct?
Yeah. So this is sort of something that's kind of interesting already, right? For a single precinct Adair, there are 237 rows of data for Adair. Okay. So this is really quite long data. If you want to know summary information about like an individual precinct, you're somehow going to be aggregating up 237 rows for that one. But if you look at the next one, Aldara here has 257. Some of these like ALG 300013, no idea what that is, has 250. So there's already a different number of rows for each one of these precincts. This is some sort of interesting data structure. The reason for it, I mean, you might be able to guess, it might be that there's a different number of races or things people vote on in all of these different precincts, stuff like that. But no matter what, we know that if we want to later reduce our data down to 1 row per precinct, which is the thing we're going to do, there's going to be a lot of aggregation involved, right? So just a thing to think about. Okay. So if I do this down here, We're just going to go through the variables one at a time, and you kind of get an idea for what these things look like by looking at some of these sort of different counts or unique values. I could have easily up here, instead of doing count precinct, done distinct precinct, which is exactly the same thing as count, except it doesn't also give us a count of the original number of rows. So if I'm just going to quickly look at something, instead of running distinct basically ever, I always do count because it conveys the exact same thing with a little bit more information, if that makes sense. Okay, so next thing, let's look at the count of the races. Okay. So this is a wonky variable here. So you look at this and we have race includes things like advisory vote 14, but it also has like races for positions. So you vote on an attorney general, you do also vote on things like advisory votes. There's all these propositions, things. You can see over here by 98 rows means that there are 98 different things people got to vote on in this election, which probably depends where they were in the state. Okay. Notice some other things like advisory vote 14 here has 1,000 or 15,102 observations, which means people voted on it in basically almost every precinct in King County. Attorney General here has 17,619. So you could imagine that people probably voted on this one in like every precinct, right? Everybody in King County probably got to vote on the Attorney General. Okay. If I scroll through these ones, we're going to see ones we might actually be interested in. The governor's race is a major executive race. We're interested in this. And you can see there's 17,619 rows associated with a governor. Okay. Well, maybe there's 17,619 individual precincts. We could actually find that out. I'm going to go up here to precinct and add something. I just want to know how many precincts there are in the data set. If I say distinct precinct here, it's going to give me 1 row per precinct value. Well, that means if I count the number of rows, there are 2,517 precincts in our data. Does that make sense? Get the distinct values and then count how many there are. Okay. Anyway. So that means if there's 2,517 precincts, but something like governor has 17,619 rows, it means for governor alone, there's at least a pretty large number of rows for governor for every single precinct. So even if we want a single race, inside a precinct, we're going to have to be aggregating a bunch of rows. Okay, it's kind of an ugly data set. We're going to keep looking at it as we go. Next thing. I said, let's take a look at this LEG, CC, and CG. I'm going to look at some values, and you guys can try and figure out what these might be. So this takes values. LEG takes values of like 1, 5, 11, 30. Has a lot of observations in them. It's not like continuous numbers. There's a bunch of like spaces in between them. What do you imagine LEG might be? Any guesses?
Maybe legislative districts.
Yeah, I think that's what it is, legislative districts. Is that probably useful for us if we want to do stuff on calculating like democratic votes of governor or president and all that? Maybe, probably not. Legislative district is not something like a unit we're going to work on. We're not going to be looking at the precincts, we're going to be looking at it. So this is an example of something that if you wanted to match your data to legislative districts and you're working on some other project, that might be a really critical sort of column. In our particular case, we're going to work our way down to figuring out essentially turnout rates and democratic votes for president, governor, and lieutenant governor. So in this case, we're interested in precinct level stuff. So this isn't something too useful to us, and it's kind of hard to even know what it is. Legislative makes sense. Let's take a look at CC. Another one, it goes from 1 to 9 and has some missing values. What might this be? Who knows? I know what it is, but that's just because I've worked with these data a long time. Another one is CG, which only takes 1, 7, 8, and 9. You know, who knows what these things are? These are examples of columns that aren't useful to us for our analysis we're interested in. I think, I forget what CC is. It's like court circuits or something like that. And CG is, I forget what CG is. Not useful to us, okay? Next, let's take a look at this. Okay, what does that result tell us? What is the contents of the counter group column?
Has the same number of rows as the entire data set.
There's no information in it.
Yeah, there's no useful information because every value in the column is the same. Every value of the counter group column is total. So if I look at King Raw here and I say like head King Raw, counter group is always total all the way down. Okay, this is the kind of thing you get also in administrative data. Theoretically, probably at some point before extracting this data set, this counter group had some other values in it that weren't like released and provided. But in this example, every row has the exact same value. This column is completely useless. Okay? Type of thing you'll encounter in real data sets. A column that's a constant. We can't do anything with it. Okay, next one. Let's look at parties. Okay, so if you have a column that's like party, what would you expect the values of this maybe to look like? Just guess.
Character.
You'd expect it to be character and probably filled with like political parties. Okay, so we're going to get something that looks like this. So it is filled kind of with political parties, but it's hard to discern what these different things are. You have values, like some of them are very common, like Dem here has a lot of observations. But then you have things like, well, what's Dem versus DPN versus Lib, LPN? If I scroll down here, NP, 565,000 of them, Rep 27,000. But notice you have a lot that have 2,517. This is one of those things that it's important to, when you're working with a new data set you've never encountered, if you start seeing numbers that rhyme all the time, you keep coming across the exact same number, pay attention to it because there's usually some systematic reason for that. Do you remember what 2,517 was?
Number of precincts.
It's the number of precincts. So this is an indication that things like CPN like this have exactly one row per precinct that corresponds to that party, okay, which is something we'll poke at a little bit later. But then you have things like, wow, 29,412 means there's many Democrat rows within each individual precinct, okay? So if you were here and you wanted to get like votes for a Democratic candidate, you might be initially thinking, well, I probably want Dem. But knowing that there's all these other sort of parties listed here is sort of an indication to be careful later when you do parties. If the party thing had just like Democrat, Republican, like independent and no party, you would be less worried about it. Here, we have 17 unique values of party, and some of them have very unclear abbreviations attached to them. So this is something just to keep your eye on as we go forward. Okay. Last thing, or second to last thing, is counter type. Okay, so what does it look like this column contains?
Maybe the names of candidates or voters.
Yeah, it looks like it's the name of candidates, probably. If you remember the 2016 election, you were in Washington, you'd remember, for instance, like Bill Bryant as a candidate for things. If we scroll through, notice there's 141 rows here. There's a lot of different like people in here. But notice there's also things that are not people. Like look over this. We have like all these people and then suddenly approved. Okay. So what does this column in general would you say this might contain? Not just the candidates, but also it has things like approved. What would you call something like that? So it's just like what people cast a vote for. It's not just a people, it's some outcome, probably. For instance, here's a presidential race. We've got Hillary Clinton and Tim Kaine. Have a lot of other people in here. And then things like maintained, no, rejected, repealed. And then notice we have something very weird. So, registered voters. So this means that somewhere in this column is the counts or probably or some indication not just of who people voted for, but also registered voters. That's kind of an odd one because you tend to think of like registered voters as like some summary thing for an entire precinct or something. You don't really think of that as like a number of votes cast. Okay. So this is something where it's nice to look through the unique values of things because you might see that columns like this are really weird. So here's a great question, chat. What are the period after 95? This is saying that the number is large enough that it has truncated it. Over here, it's because this is like 95,000 or something like that, because there's a number of registered voters for every single race in every single precinct. So there's a lot of them. The ones that have the periods like that, which are almost all 95,000 or something, are ones that are probably in every single precinct race combination. There's a lot of them. Like this, times blank voted, times counted, times overvoted, write-ins. This column contains an enormous amount of information. This is like how votes were cast for what, okay? But the thing is this column, right? What it contains is just these like names or something. It doesn't contain the number of votes for this or anything like that. If we go to sum of count over here, so what does sum of count contain? So if we run a count on a variable like sum of count like this, and the result comes out like this, what do you think that this sum of count contains? Let's look at the entire data set again. So if you have this, let's say we look at things like all these Adair precincts. We see how we have like Adair. These are all advisory vote 14s in Adair. Notice for all of these, most of the data is the same. Counter group total, party is NP. Then we have counter type is maintained, registered voters, repealed, times blank voted, times counted, times overvoted. If I move to the next column, we see sum of count here is a number. Okay, so let me ask you, what in plain language does this number here tell us about Adair and advisory vote 14, or let me go back up to 14. So this row here, we have 183. What does this tell us?
That 183 people voted to maintain advisory vote 14.
Exactly, right? So this is starting to parse out what is the contents of this data frame. Okay, so I'm just displaying, I'm not displaying the number of rows here. This is actually just the whole King Raw data set with its 643,000 rows. I'm just showing like the first 10 observations here. So if we look at this, let's say we go down to this next row here, which says registered voters. So what does 519 mean for this row?
That there are 519 registered voters in that particular precinct who participated in that race.
There are that
Or-
many registered voters. Now, the thing is we'll see, they didn't necessarily participate in any way, but they are the number of registered voters. And what's cool, you'll see, that kind of tells us this actually is the number of registered voters. The number of people registered to vote should be the same no matter what the thing on the ballot is, because that's the number of people who can vote in that precinct. So theoretically speaking, you would expect this number should be the same for every observation in a dare, okay? Well, if we look down, you'll see 519 here too. This is still in a dare. 519 here, 519 for registered voters, 519. These are all like a dare observations. This tells us it probably is just a lot of redundant information that they've stuffed in there. Okay, but then what do you think something like this means? So look, this particular advisory vote 14, it looks like people could vote to maintain it, or they could vote to repeal it. You'll see that there's 183 maintained, 251 repealed. Well, what is times counted over here? What would you think times counted means? Any guess?
Is that literally the number of times the ballots were counted in that precinct?
Yeah. So this is a really dumb thing about this data set. Notice that they've mixed actual counts of votes with summary data about the precinct in the same column. So you have the number who voted to maintain, the number who voted to repeal, the total number of people eligible to vote in the first place, the total number of ballots they received, and then 51 times blank voted. What do you think that is?
The number of times people didn't select an option.
Yeah, so logically speaking, mathematically, you would expect the number of maintained plus the number of repealed plus the number of blank voted should equal the number of total ballots cast, 485 times counted. Does that make sense? So when I first encountered these data, that was the exact process I followed to figure out what all these things meant. I just do simple math, and if things start to add up uniformly and systematically, your hunches get confirmed or rejected quite quickly. If we move to the next precinct, for instance, not precinct, but the next race, we see 220 maintained, 222 repealed, 43 blank voted. I'm just going to say 220 plus 222 plus 43 is 485. If I scroll to the next one, there were 485 counted ballots. So if you just do this sort of math, you should see, oh, these things add up. This is how you can figure out which of these things mean what in these different sort of rows. Okay, now you'll notice that there is more art to that than science exactly. This is me just being like, well, these things look like they should add up to this, and I test a hunch. This is how actual data analysis with an unseen data set really tends to work. You sort of have to figure these things out. If you don't have a code book, you play with it and you figure out how things match and they fit together. Does that make sense? Are there questions about that? Okay. So this tells us a bunch of useful things, right? If we want to do something like let's scroll down to I'm going to look over here and go down to a race we might actually care about. Let's go to like governor here. So we see like governor's race here. If we wanted to know, if we wanted to know how many people voted for the Republican governor, we would have to look over here and find the governor's race. Within the governor's race, find the Republican candidate, and then find the number of votes over here. And then we'd have to do something like take this number of votes divided by the times counted, or maybe the registered voters, or maybe this number, some ratio of this to the Democratic vote, which would be Jay Inslee at 256 right here. Okay. So we have to grab all sorts of different pieces within each one of these races to piece together things like the voting percentage. Okay. So let's move on. Okay. So now that we've taken a look at the data set and we have an idea for its structure, let's actually try and answer some questions here. So the idea here for this assignment is that we're going to focus on 3 major executive races in Washington, right? We're going to take the president's race, which is president and vice president. It's always a joint race because they run together, right? The governor's race and the lieutenant governor's race, because in Washington state, you vote separately for the governor and the lieutenant governor. Okay. Within these races, we're interested in a few things. We're interested in the turnout rate for each of these races, which we want to calculate as the times votes were counted, whether they are for a candidate, blank, write-in, or overvote, divided by the number of registered voters. So this is the total number basically of ballots received divided by the number of people eligible to send a ballot in. That's how we're going to do turnout. It's not a perfect turnout measure, but it's the way we'll do it here. Because an ideal turnout measure would capture like the number of potential voters and then the registered voters and then the actual number of registered voters who cast votes. But this is not a political science class. We're going to be simple about this. Next, we want to get differences between precincts that are in Seattle versus ones not in Seattle. There's no documentation for this, so we're going to have to figure out how to do it. And then last, we'll calculate precinct level support for Democratic candidates in King County for each of these 3 contests. And we're going to calculate that as the percentage of votes for the Democratic candidate out of all votes for all candidates or write-ins. But we don't want blank votes. That's people who didn't cast a vote for president, or overvotes. And overvotes are where people cast multiple votes within it. So somebody simultaneously voted for the Democratic and the Republican, it was thrown out. And so we wouldn't want those. But those ones are already in sum of count. We'll get there. Okay. So what we're going to do is we're going to do the data management for this. Next week, we're going to do the visualization and the sort of like looking at the results. Okay. So the goal that we're going to do next, right, or that we're going to work toward is having data that have basically 1 row per precinct with about 7 variables. We need some identifier for the precinct, some indicator of whether it's in Seattle or not, the size of the precinct in terms of registered voters, a turnout rate, and then 3 columns that are the percentage Democratic support for president, governor, and lieutenant governor. Later, we'll make these into 1 column to plot them nicely in ggplot, but it's easier to kind of make them individually. Okay, so let's get to it. So we've got my King Raw data here. If I have data that look like these that we've looked at, and I want to get this down to only the data for the races we're interested in, how should I go about doing that? So I want to take my very large number of rows and reduce it to only the rows associated with the races for president, governor, and lieutenant governor. How am I do that? I like the look of that. First, I'll check to make sure that works, and then I'll talk about why it works. So, does that work? Governor, lieutenant governor, but I'm missing president and vice president, so we'll check on that here in a second. So, if I look at King Raw, let's look at, I'm just going to say, look really quickly at all the races, okay? So we know governor and lieutenant governor are right, the ones provided there, but there's something off about president and vice president. I'm going to scroll down and look for it. Ah, there's our issue. It's US president and vice president. So if I just put US in front of there, that should give us the rows that we want. So you notice the way that I kind of figured out how to do it. If this was a fresh data set to me and I knew I wanted governor, lieutenant governor, and US president, vice president, I would just display all the unique values of race and go down and find them, pull them out, paste them in here, and then filter down to those rows. So if I go ahead and do that, now what we see is a data set that's been reduced to a mere 65,000 rows. So we're at 10% of our original data set. And our rows are now just like a dare governor, a dare lieutenant governor, a dare president and vice president, and no additional things in a dare. We just have 3 different races here. That looks like what we want. Is it clear how this works, this statement here? Does anyone have questions about that? This is just saying take my king raw data and then filter, that is go to specific rows. I want the rows where race is equal to any one of these 3 things on the right. Percent in is just the multiple equals. Nothing ambiguous there. Okay. So let's assign this to, let's say, let's go like that. Okay. So what I'm saying here is I'm just going to assign king raw to king relevant races, the races that are relevant to the work that we're doing. This is sort of an arbitrary name. You can name whatever you want. You'll tend to find that I use a uniform object name syntax of underscores, spaces between words, and everything lowercase, because I don't like having to type uppercase things. And it's easy to remember where underscores are, but hard to remember where capitals are for me. That's just me though. Okay, so we have these races. Okay, so the next thing we want to do is we want to determine which precincts are in Seattle and which ones are not in Seattle. I say here that you should look at the values of precinct and see if you can figure out what uniquely identifies them. So all the Seattle tracks have some unique naming scheme. Okay, so let's take a look at this. I'm going to say distinct values of precinct. Right, there's a lot of them. There's 2,517 of them. If you didn't have any other sort of clever technique to search through them, you could literally just browse until you find what you're looking for. So, oh, actually, here it tells me there's a maximum I can browse to of 100 deep. So what I'll do instead is, let's say, just pull out precinct, its unique values. There are a lot of them. Okay. I could print these all day long, basically. Let's let it run. Okay, so it's omitted down here. So we see down here, we're only going to do about MI. I could say, show me the last 500. There we go. Okay, so I've looked at the last 500 results for my precincts. So if you know anything about King County, most of the people in King County live in Seattle. If most of the people live in Seattle, it should mean that there's a lot of Seattle precincts. Okay? So based on that, you could probably pretty easily imagine that things like SCA 46-2339 is probably a precinct in Seattle. I think that's a pretty fair assumption to make. Okay, so if it's the case that everything in Seattle seems to follow a similar structure like this, how might I create a variable that would tell me when something is in Seattle versus when it is not in Seattle? Anyone have a general idea? Plain language, not necessarily code.
Using the case1 function and our combination of the case1 function and the substring function.
Okay, so generally in sort of plain language terms, what is that thing going to do?
It'll create a new variable, or you can use it to create a new variable. Like you could mutate something, create a new variable that says if a value within the precinct column contains the string SEA, then it should be labeled Seattle in this new variable column. If not, then it'll be not Seattle.
Okay, that is an excellent explanation. That's very clear. And the kind of thing that I would recommend in these sorts of cases is before you start to write code, sort of say something like that to yourself in your head. Be like, what is the intention of this thing that I'm going to write? What's it going to be? And that was actually a really nicely logically laid out thing. Be like, oh, well, I want to look in a string to find SEA. If I find that thing, I want it to be Seattle. If I don't find that thing, I want it to be not Seattle. Okay. With that knowledge, let's do that thing. So if we're going to create a variable, like you suggested, we'll create a variable with mutate. Now, what I'm going to do is I'm just going to say, let's name the variable something like, it's location. The location is going to be either in Seattle or not in Seattle. So if I want to create a variable, so you suggested case when, but there's a simpler function to also do this too. So if I have a case where I want to run a logical test and I want to produce one value if that test is true and another value if it's false, what do we normally use for this?
If else.
Yeah, the if else is the most straightforward way to do it. I tend to think of using case when mainly when I have a third condition or something, or I want to do special handling of NAs or something. So here I'm going to say if else. Okay, so I'm going to say location is if else. So if I want to select to create a logical statement that will return a true anytime it sees any of these values, what would I give it as a logical statement? What would be an example? So we talked about using, for instance, string sub is one. How could we do it with that? So let me get help on the string sub function and we'll see the way string sub works here. So string sub is for extracting and replacing substrings from a character vector. Its syntax looks like this. We say string sub, some particular string. The string is going to be like a column in our data set that's character data, and we're going to extract some portion of it. We then say we want to start somewhere and end somewhere. And the way it works is it will begin, say if I give it start equals 1, it will start at the first letter of the string. If I do something like, say, 5, it's going to go from the first to the 5th character in the string. Okay, so if we see here, the S here is the first character, E is the second, A is the third, then there's a space, a 4, 3. So based on that, if I wanted to pull out the relevant part of this string, what would I write with substring? So I say substring, we need to look in the variable first, right? How would I do that?
Precinct?
Yeah, we're going to say we want a substring from the precinct variable. And then we're going to say we want to start at its first letter because we're looking for like SEA right now, right? We're going to start at its first and then, well, SEA is 3. So we're going to say we want the first character, second, and third. Okay. So I'll show you what this is actually doing here really quick. If I say, let's take substring here, substring 1 to 3, and I'm going to say king relative races precinct. There we go. Could not find function. Oh, it's because it's string sub. Duh. String sub. Yeah, look at that. They're all 3 letters long. If you remember, the first one was Adair. One of the next ones was Aldara, whatever. All string sub 1-3 is done is grab the first 3 letters of every precinct, no matter what. Okay, so let me fix this one here. Okay, so what do I want to do next here? So if I want this instead of just grabbing these 3 letters, if I want to see if they're equal to Seattle what should I say here? Yeah, I like that. If I say equals SEA, this thing is, instead of returning the letters, is going to return a whole bunch of trues and falses, mostly falses here because all these first ones are not in Seattle. Got a million of them. Okay, so I'm going to take this thing I just wrote, I'm going to put it in here. Okay, now if we remember how if-else works, right? If-else works by saying, if this statement is true, the next thing is going to be returned as the value of if-else. If it is false, the third thing or the next thing there will be returned. Okay, so what should I have here? I'm going to write it down here to show you. Yeah. So I'm going to say Seattle, not Seattle. And I'm just going to run this statement. Actually, just going to run the first few to give you an idea what it's doing. So what this has done is, if you remember, all the first rows are basically a dare. So it's going to test to see whether this string sub first three letters are equal to SEA. If they are not, it's going to return not Seattle, as it did here. If they are equal to SEA, it would have returned Seattle. Okay, so I'm going to put this up in here. If we run this here, we should have a new column called location, because it assigned it to location that is not Seattle versus Seattle. So just to show you that this worked, I could say do filter location equals Seattle. And we should see all the precincts here are like SEA 11, 12, 56. I look over here, their location is in Seattle. So there's our question in chat. Are there benefits or disadvantages to maybe using string detect instead of string sub? So the exact equivalent of this with string detect is actually the way that would have initially occurred to me to do it, but I haven't introduced it in the class yet. Instead of using if else here, I would use if else. Instead of using string detect, I would say, sorry, instead of string sub, I would say string detect precinct SEA like this, and it would do the exact same thing. This would say, look at the beginning of a string for SEA, return Seattle if you find it not Seattle. I'll teach you this in week 7. This is regular expressions.
If the caret's not there, does it just detect then for like the sequence SEA anywhere in? Okay.
Yeah. So this is a really good, you want that there, the caret there to look in the front. So we've now been able to find these precincts that are here in Seattle, but there's a problem. Anytime you do some sort of operation like this, when you're sort of searching for something, you need to validate your results and make sure you get what you're expecting to get. So in this case, we have all these nice Seattle precincts. Okay, what I recommend doing is doing something like a range on the thing you were sorting on, like the precinct. Look at that, but then look at the start, but also look at the end. Does that look like a Seattle precinct to you? Okay. So this reveals a flaw in our strategy. We've searched for Seattle precincts, but we've unfortunately found Seaview, Sean, Sylph, and then our Seattle precincts. Okay. So anytime you do something like this, make sure you're getting what you're expecting to get. How could we fix this so that we get all of our Seattle precincts, but not these other ones?
Could include the 46, like the space 46 maybe.
So the thing with the space 46 that's problematic is not all of them are space 46 or space 4. But you know what all of them are, as suggested in chat, is all of them are that are SEA space. So we don't so much need the number, but we do need the space. Every single one of them is SEA space. How would I change this syntax up here to handle having a space?
You just put a space after the SEA, after the two
Okay.
equal signs, maybe.
So there's an issue here, though. Do you know what the issue we see here is? If we test to see whether this string here is equal to these characters over here, do we see a problem?
Oh yeah, it's we're telling it to stop looking at 3. So I guess we'd have to tell it to stop looking at 4.
Exactly. So now we're saying we want to look at the first 4 characters and make sure that they're equal to SEA space. If I do this now, we'll see we have at the bottom only SEA precincts, and at the top, only SEA precincts. We've gotten exactly what we want. Okay. I could also do the exact same thing for the string detect version. Just by adding the space there will give us the exact same result. This says look for anything that begins with SEA space. You get the same result. Okay.
What was the thing you just deleted there? Is you used it to look at the beginning and end? DE something?
What was that? Hard for me to hear you.
You just removed something under filter.
Yeah, I was just using arranging by precinct.
Yeah,
So
you had another thing inside arrange a second ago. Desk. Yeah. So what does desk stand for?
Descending. So it reverses the arranging. So if you have it set to arrange precinct, it will alphabetically display them. If you have descending, it's reverse alphabetical. And so the thing is because this is something that should always be SEA space for anything in Seattle, if I arrange it alphabetically forward and backward, I've ruled out the possibility that there's anything other than SEA space stuff there because they both begin with it. So this is a common thing I do. Anytime I make something, I sort of check the top and check the bottom, because if the top and the bottom are right, the middle's usually right too, unless you have something that like is unclearly ordered. Okay.
Thank you.
I'm going to delete a couple things, but leave. I'm going to leave this here as a example in case people sort of want to see this later. Okay. So now what I'm going to do is I'm going to assign this back to let's say yeah, I guess I could just run it back to the same object. Okay. So now what we have, if I display King Rel races, is I've got the same data as before, limited to only, well, here I shouldn't be filtering actually. I don't want only Seattle. I want, that's why I shouldn't do that. Now I have to reload the whole damn thing. Okay. There we go. Now what I have is I do have all of the races in our King County data, right? But I now have an additional column that has their location. So we're slowly narrowing down on sort of what we want for our final sort of questions. We have exactly one more question for this homework. We want to get the registered voters and the turnout rates for this. So we want to calculate turnout rates as the total votes, that is normal votes, blank votes, overvotes, and write-ins for the presidential race divided by the registered voters. So this is just going to be the turnout is equal to total votes divided by registered voters. So if we remember, we got some sort of weird stuff in this data set that we're going to have to pull apart to get what we want. Okay, I give a hint here that says you're going to want to look at counter type and sum of count at the same time within race or within precinct and race, and figure out how they relate to the other ones to sort of tally up what we want. Okay. So if what I want to do is take data that look like this, just for clarity, I'm going to get rid of things we don't really care about at the moment. Let's say also minus. Okay, so if what I want to do is I want to get, say, I just want to get right the number of registered voters, and I want the total turnout for vote. That is the total number of people who cast a vote in each one of these like precincts. How might I go about doing that? Anyone have an idea what I need to get?
Pivot on precinct.
So what was that?
Could you pivot on precinct?
Put it on precincts. Pivot. Pivot on precinct. Yes. Yeah. So the idea, right, is we might want to pivot on that so that we have sort of a that would give a. So what would be the result of that you're thinking?
You have one column per precinct.
Yeah. So you'd have sort of well, one row per precinct and then multiple columns for counter types, right? Okay. So that is a great idea, but there is one problem about doing that. Do we remember sort of how many unique values of counter type there are? Do you remember that counter type has a lot of different values? So what might we want to do before we do that pivot?
Maybe pull out the values that we want, and then we can get rid of the rows we don't need.
Yeah, so that's the idea, is we can do one big filter, essentially, to cut down to only the things we actually care about at the moment. So if what we care about is the number of registered voters and the total votes counted, what do we actually need out of here? What rows do we need?
So where counter type is equal to registered voters, and also or where it's equal to times counted.
So that makes a lot of sense to me, right? So the idea here is, what do we want, right? We want the number of registered voters as a denominator. And then as our numerator in this sort of equation, we want the number of votes counted. But if we remembered when we went over and inspected the, when we inspected the sum of count, we discovered that the times counted here is equal to the number of all votes cast in a particular election. So for instance, if we have the race for governor here, the number of times counted, 485, is equal to the 256 Jay Inslee votes plus the 224 Bill Bryant votes plus 1 write-in and 4 blank votes. That ends up being 485. So we could sort of manually tally all these up using some other way, but the easiest way is to just grab the times counted. So if we filter down to times counted, we'll end up with this. We'll end up with 2 rows per precinct per race. Okay. Something else you're going to notice, what does these numbers look like for all the different races in a dare? And in fact, in all of them.
Can you repeat your question?
So what does, say, these counts of votes look like across all the different rows for a day and all the different rows for like Aldara? What do we notice for governor, say lieutenant governor, US president, vice president? Yeah, they're repeated, right? The idea, right, is that it doesn't matter which race you're looking at for registered voters, because that's just the number of people registered in the precinct. The number of times counted, the total number of ballots cast, is again always the same for every single race. So technically speaking here, we actually really only need a single race is sufficient to count everything we want. There's no reason for us to even be working with multiple races here. So, and this is actually a point here that I brushed over to focus on this, is that I say here we want to calculate the turnout rate as total votes for the presidential race divided by registered voters, but it's actually not unique to the presidential race. Every single race has the exact same turnout rate by this definition. So how would I filter down to, say, the president's race? What do I got to add? We could do it inside the same filter with an and statement. So I could say something like race equals US President and Vice President. Probably break it under its own line for readability. Okay. So this has trimmed us down to having like sort of the minimum stuff we need. Technically speaking, we're going to end up getting rid of a bunch of other stuff. But okay. So what's the next thing we want to do here? If we want to calculate the number, the times counted divided by the registered voters, what do I got to do next? How can I get this set up so I can do some math with it? There is no reason I use an and versus a comma. I just think it's weird that a comma can take the place of an and, so I use an and myself. They're equivalent for filter. And, however, would work in every logical statement in R, whereas a comma would only work in filter. Okay, so what do we need this to look like if we wanted to say take times counted and divide it by the number of registered voters? Yeah, we probably need to pivot our data wider, because what do we want, right? We don't want a sum of count column and a counter type column. We instead want a registered voters column and a times counted column so we can do math across them, because we can mutate across columns. Okay. So what is that question there? How can we delete rows including lieutenant governor and governor? Are you asking how to do it or why I'm doing it?
Asking how to do that, because here is like we. Oh, gosh.
Yeah, sorry, I added that sneakily. Yeah. Okay.
Thank you.
So what we'll do here is, so if we want to pivot something wide, what is the function to pivot something wider? It's pivot wider, yes. So if we want to pivot something wider, do we remember the syntax for saying how we're going to pivot stuff wider?
Isn't it like a new variable name and then the column to get the new column names from, and then the column to get the values from?
More or less. So if we look here, what we're going to have is we only actually need to give it two arguments here. We're going to say names from equals name, and then values from equals value. I don't think we don't technically actually, we don't have to give it new column names because it's going to create them based on the names from column. So if we want to create new columns that contain the sum of count and the columns are named after registered voters times counted, what argument do I want to give here? So the first one we're going to say is names from. Where are my names coming from? What's going to get turned into new column names?
Counter type.
Yeah. Counter type. So this is saying that instead of having a counter type column, we will now have one column for each unique value under counter type. So we're going to have a column for registered voters and a column for times counted. Okay. And then where do our values come from?
Sum of count.
Sum of count. So this is saying that we're going to create new columns. We're going to create a column for registered voters, and under it, it's going to have numbers like 519, 763, 557, 472. We're also going to create a column called times counted, which has numbers like 485, 625, 476. If I run this, what we get now is one row per precinct, right? Now we have a registered voters and a times counted column. Okay. So now, how can I get my turnout rate?
You could create a new column with mutate and do the math into that column.
Sure. And that's just going to be equal to what?
Times counted over registered voters.
If we scroll over here, we now have a turnout rate. Okay. So the idea here is we're just taking times counted divided by registered voters. So if you were going to calculate something that you know should be a rate, would you logically want to check to make sure this column looks like? Are there any sort of values you shouldn't see in a turnout?
Greater than 1?
Yeah, so we probably shouldn't see any negatives, and we shouldn't see anything above 1. So I'm just going to really quickly say, let's pull out our turnout column. Let's give a quick summary. So we see here that we do have 2 missing values for some reason. We might look into those. They don't matter too much, but we might look. We could see that the highest is 0.958. 95.8% turnout is really high, but it's not impossible. Minimum turnout of 33.3% is pretty low, but it's not impossible. We don't see any negative values or anything over 1. So it looks like we calculated this at least plausibly, right? Okay. I'll actually add that down here as a check. Okay, so we have, oh, I don't want to rewrite to that, but so what I want to do is, so this one right here has like precinct race, party location, registered voters, times counted. The things I'm actually interested in here, right? I need to keep the number of registered voters and I need to keep the turnout. So this is kind of what I want to go and bring to my, as it says, registered voters and turnout rates, what I want to bring back to my original data. Okay. So, oh, and here's to answer that question in chat. Why do we use times counted? So the reason we use times counted is if we looked at the original data, which, so the original data look like this. If I scroll over, say, within a dare for the governor's race, we'll reveal that if I take the total number of votes cast for the governor, that's 256 from Jay Inslee, 4 blank votes right here, 1 write-in, and 224 for Bill Bryant, it gives me 485. It just so happens that instead of manually doing that calculation, because this is a stupid data set, they have already calculated the total number of votes cast, and I can pull it from times counted. So rather than manually doing it, oh, are you asking about the backticks?
Or I didn't ask it clearly. Yeah, I asked why we use backticks.
Okay. The reason I'm using backticks is because the variable names have a space in them. If they have a space in them, if I don't use the backticks, it thinks times and counted are 2 different objects.
Oh, gotcha. Thank you.
Yeah. Sorry for misunderstanding the question.
I remember a while ago you were going over how backticks had apostrophes and double quotes actually worked in a lot of the places that backticks used to be mandatory.
Yeah.
But I noticed that they don't work in mutate. Can you remind me of what that rule is? It's when they don't work.
Yeah, so it's actually really dumb that they work anywhere, but yeah, they really shouldn't work in a lot of the places that they do. So the thing to remember basically is that 9 times out of 10, you probably need the backticks. Anytime you're referring to an actual variable in the data set, you'd probably need the backticks. Quotes should really only be used if you're not referring to a variable, but you're giving it a string, like you actually want to provide like US president and vice president. Like this is something I'm checking against. It's not a variable in my data set, so I want it quoted. These here are not variables in the data set either. I could theoretically, I mean, God, does this work? I hope this doesn't work. That would be really stupid if that works. Thank God that doesn't work. Okay. So this is one of those things where they made it so you can do things like this. And it will like still remove counter group. In my opinion, I understand why they allow you to do that, but it's very confusing that you can quote or not quote them. The reason they did it though is because it makes programming in dplyr a lot easier. Programming isn't writing functions that use dplyr commands much easier if things can be quoted or unquoted, but it's very confusing because the quotes work here, but they don't work down here. Okay, actually they do work there. They don't work here. Okay, The reason they don't work in mutate is in mutate, you can actually give quoted things like text and use them for reasons. They don't want to be converted over to variable names. You just kind of have to build an intuition for it. It's one of these things where I don't like it. Just don't quote things unless you know you need to quote them, and stay away from the dangers of this is what I would say. Yeah. So this next one in chat here, when I try to do the pull function, it says the turnout object isn't found. Yeah, this isn't going to work because I haven't actually assigned it back to King Rel races, and I don't want to yet. So I'm going to actually quote this out here. So the idea here is we have this thing that looks like this with registered voters, times counted, and turnout. The thing is what we want to get this registered voters, the turnout, back onto our original precinct data. Now, if we want to take something like this that we've created and put it back on another data frame, how might we go about doing something like that?
Assign it to an object.
We might assign it to an object. So I'm going to say something like King turnout. And then what if we assign it to an object like this, how would we get it back onto our other data frame that looks like this? How would I add a turnout and a registered voters column to this data set? I like that in chat there. Some kind of a join. Let's take this thing and stick it back there on our previous data set. Okay. We might not necessarily need to do that yet, but I'm just going to show you how to do it. I forget whether in the next part we need it joined or not. But if we wanted to do that, the first thing I would do, right? We see our data look like this. If we're interested in the voter turnout and the number of registered voters in a given precinct, what columns do we actually want from this data set here? Is there anything we don't want from this data set?
It seems like you only need precinct and times counted, honestly.
Well, we don't necessarily even want times counted. So I'm just saying after we've already calculated this, what do we want at the end?
I'm sorry, turnout, I misspoke.
Yeah, so we want the precinct, we want the turnout, and also I'll tell you right now, we actually do want the registered voters because we're going to use it in part 2. But that's all we need because we already have one row per precinct. Everything is US president, vice president. Things like party and location don't actually matter here. This is the stuff we're actually interested in. And when you're working with sort of like sub data sets and things, I very strongly recommend that before you're going to like join a data set, pare it down to only the minimum necessary variables. Don't keep a bunch of junk you don't want. Sort of trim this thing down to only what you care about. Write a data frame like this. Precinct, turnout, registered voters. If we join this back to our previous data, we don't even have to tell it how we want this join to be done because it only has one column in it that still exists in our original data frame. So if I say something like this, King relative races, I'm just going to say inner join, King turnout. You can do any join you want. They're all going to work and do the same thing because there's no missing values here. If I do that, it's just going to work. It's going to automatically join on the one common variable. We're going to get our original data frame with Adair, governor, this junk, sum of count, location. And now there's the turnout and the registered voters repeated for every one of these rows. So if you wanted to join it back on, that's how you can do it. Okay. And that's it for part 1 of this homework. So as tragic and annoying as this data set is, guided through it, it's not so bad. But I can understand if you'd struggle a lot getting to this point on your own. It's a tough data set. Okay, so here's an error. I'm getting mutate input turnout.x non-numeric argument to binary operation. I have one set around them in my code. Turnout is times counted. So can you copy your exact code that you have here, like from this whole block into chat? And as far as that next question, I'm not sure why we needed to join. At the moment, we actually technically speaking, we don't need to join it back on. I was just showing how to get to the jump of the next part, because we're going to eventually need other stuff in that data frame, like whether or not it's in Seattle, and we're going to need the other races to get turnouts and voting percentages. So I'm just showing you that to give you a jump, because it's sort of not a logical jump that we need to create an object for this and then join it on here. Gives you a little jump for next homework. You might not need to do the join there, but you will need to do it a little bit later, if that makes sense. Okay, so here's the code you've got. Let's see what you got. Okay. Okay, so king relevant race. So I'm going to use my object here. King rel race. That looks good. That looks good. That looks fine. Does this run? That runs perfectly for me. So most likely what the issue is check your king relevant races and make sure it has these same columns that look like this. So check that object and see if there's anything funky about it.
Yeah, thanks. I thought that might be the case.
Yeah. Yeah, it's probably just something up a little bit higher, like either this where it was created up here or right here, because that's the only two things we did. Most likely just one of these, there's some typo somewhere, and then you'll fix it. Let me know if you can't find it though. Okay, anything else?
Can I ask a question, not over chat, because I don't want to take more? When you do the inner join, you're still going to have that like LEG, CC, and CG, right? Because that was in the original.
Yep.
Okay.
Yeah, you could actually get rid. So this is one of those things where I didn't bother to do it, but as I said, these are kind of useless. If we really wanted to, we could go all the way up to sort of like right here or something like that. We could easily just drop them anywhere along here. We're never going to use them.
Right.
So we could dispose of them anywhere. I was lazy and I didn't bother doing it, but you can get rid of them.
Okay.
Same thing with counter group. It doesn't contain any data.
For this question, you're only asking for that one set of code that says king turnout, right?
Yep, that's pretty much here. So what we want here, it says, is just get right the turnout as total votes for the race divided by registered voters. 100% of that content is contained right here. So that'll do the job. This is just, this was me testing code from chat. Don't need that. And then this is me just joining it on to show you how you add it back on for a later step. This is all you need though. And in your actual one, it might be a good idea so that you can display that it works to do something like head king turnout to show it in the actual document, right? Yeah. Maybe even including a check like this. Something like that. Anything else? No other questions? Broader questions? Anything?
Speaking of voting,
Chaos reigns. Yes. It's gonna be a fun week. Trying to like send in a prospectus draft this week, and I'm like being so very productive. Yeah. Well, if I don't have anything, feel free to hop off. I can also stick around for a little bit longer if anyone has any kind of questions or anything, but that's all I got. You'll find that the labs sort of for these later homeworks are going to be pretty short because while the assignment themselves can be traumatic to work on your own, they're actually pretty quick to work through if you have somebody guiding you who has done them like 25 times, unsurprisingly. Yeah.
Can I ask one question about like wide versus long from a utility point of view?
Yeah.
It seems like if you were going to throw this data into ggplot, having the really, really long format would be the most versatile in that case, but it's just hard to look at.
Yeah.
Okay. Are there any other situations that, I mean, obviously wider is a little easier to look at, but when else might you want it longer?
Yeah, so almost all statistical routines demand long data. So it's basically sending things to ggplot or to stats. Basically, that's all long data. So the only times wider data is really used is to make it more digestible by people to look at, or for the rare statistical routines that demand wide data. A couple plotting routines demand wide data, like base R ones, like matrix plot. But you probably don't want it. The only statistical routines that use wide data are basically structural equation models, and nothing else really uses wide data.
Okay. So it's almost like if you're the person sitting down with this weird code, you're trying to get it a little wider to make sense of it, but then you may end up collapsing it back down or making it longer again later.
Yeah, basically every data set I get is going to end up being turned into something hella long real quick, because long data, as it turns out, is just much easier to work with for most sort of operations, because the tidyverse is essentially, it's built around working with long data to make it so you don't have to come up with like custom ways to work with every single data set. If everything's in long format, what is that that classic? I forget if it's Dostoevsky or Solzhenitsyn, or I forget exactly who's like, every happy family is exactly the same and every unhappy family is different, right? You know, it's like the whole thing. Data's like that. Every shitty data set is different in its own shitty way, but every clean, good data set looks exactly the same. And because of that, if you get them to that nice long format, you can use the exact same tools every time to fix it and work with it. And so your goal should be to get it into this beautiful format.
Okay.
Tolstoy.
Cool.
There we go.
Wasn't that Anna Karenina?
Yeah. There you go.
Oh, yeah, sorry. There it is. Yeah, Alex. Nice.
Yeah, mixing up my my Russian authors, which, having been a Russian studies major, I really shouldn't be doing that, but it's been many moons since then.
Thanks again.
Yeah. Okay. We'll see folks later. If you got any other questions, feel free to hit me. Otherwise, I will jump off once everybody is basically out.
Thank you so much.
Absolutely.
Yeah, thank you.
Dan, hit me up on chat and email too if you like run through this and something suddenly stops working. Make sure to hit me up. I will be obviously much less available tomorrow, so today is a better time to do it. Okay.